Good morning. My name is Jody, and I will be your conference operator today. At this time, I would like to welcome everyone to the CA APM Global User Community Webcast conference call. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. I would now like to turn the conference over to Mr. Manish Parikh, Community President. Please go ahead, sir.
Good morning and good afternoon and to everyone. Hope everyone is doing well. My name is Manish Parikh. I'm the Community President, and I will be heading up the webcast today. A few announcements that I wanted to make before we get started and before I introduce the presenters. One is I know CA World is coming up next month, and we are going to have our April webcast right before, maybe just a week before, a couple of days before it. So I wanted to make you guys aware of that. The April webcast on 18th of April will be focused on CA Executive Insight, and it will be presented on how it works with APM. We currently do not have a resource name, but we'll have that information on the community website as soon as we have that information. The other thing that I wanted to mention was about during the CA World, there is going to be a service assurance social taking place, which is going to basically focus on CA APM community and a couple of other communities which are part of the service assurance portfolio. And the details on that social will be posted on our website, but I will tell them to you now. It's called the CA User Communities Reception. It's a small 1-hour social occurring on Tuesday, April 23rd from 5 to 6 p.m. And it's going to happen in the Breakers E and F room. Once again, I will post all that information onto our community website. That will give us a chance to socialize within our community as well as other community. We also have possibly product managers that might be attending, so we can have a good interaction with them and also have a Q&A session. So I'm looking forward to that. That should be very interesting for us. And pretty much those are the announcements that I have. I hope you're looking forward to today's webcast. Today, we are going to talk about, well, let me go ahead and introduce the presenter first, sorry. Jean-Pierre Gueguen, sorry if I butchered your last name. He is a Principal System Development Manager at NEC for the product Invariant Analyzer. The Invariant Analyzer does predictive analysis for the service assurance model. And he's here to present information on IA, which is Invariant Analyzer working with APM and SOA. So let me introduce to you Jean-Pierre Gueguen. Take it away.
Thank you, Manish. Yeah, my name is J.P. Gueguen. I work at NEC. And with me is also Yusuke Nonogaki-san, who is IA engineer for the technology I'm going to be talking about, and specifically how this technology works with APM, and as well as CA SOI. There's a SOI component that I'm going to present, and there will also be a demo. So that's the agenda. First, I will talk about the product and technology itself, and this whole concept of analytics. Then I'll show how the product position relative to your environment with CA APM Introscope, and then potentially with the SOI as well. And then we'll move to the demo. So just to set the stage, what we're talking about here, right, is this type of issues that, in fact, APM users have told us about Typically, users don't like it when something is wrong and fails to be detected. Right, that's the basic. Resulting in being in fire drills, reactive mode, so crisis management. Also, when a performance issue is reported, the whole triage process can be challenging and take time and resources, right? Many of you have been on calls where each domain manager reports on their area and the network seems fine, the database is okay, the application seems okay, but still there is a problem. So this is the type of situations that this tool, this solution is addressing. Also, when there are too many false alarms, we hear, that can be potentially a problem. There's so much data available, performance-related data available today being collected by your monitoring environments that it's becoming increasingly challenging to use this data for actionable decisions. So again, this is what this tool does, and use this data, make use of that data in a more automatic way. So introducing Invariant Analyzer, that's the name of the product. It's a predictive behavior analytics tool dedicated to system performance management. It offers automated predictive diagnostics across multiple IT domains. So these three terms are important. Automated, I'll get back to that. Predictive, that's one of the, increased predictability is a major value of these type of tools. Across multiple IT domains, because potentially the data coming from it can come from multiple sources, right? Meaning multiple IT domains. It's designed for closed-loop integration with your CA service assurance. Closed-loop, we mean the capability to go from IA to CA environment and from CA environment back to IA, and I'll show that in the demo. It has a knowledge base that is to remediate or to facilitate the remediation of anomalies that happened in the past. So the IA archives problems and performance-related anomalies and is able to recognize if it's similar that something happened in the past. And this can be used for, to see what was done and how it was remediated at the time. And so it complements and enhances the return on your CA investments. So how does it work? I'll just do a technology refresh here on these analytics tools. Typically, they are very different from conventional monitoring in the way that most of the monitoring tools are threshold or rule-based, meaning they look at the values of individual performance metrics, and then you have to decide if that metric is important to track and to alert on. These technology, by contrast, don't look at the individual or specific values of individual metrics, but rather the relationships between the metrics in the data set. So it looks for correlations between all these metrics. That's why we call invariant relationships in the case of IA. An invariant relationship means that performance metrics have some correlations over time. Their behavior is correlated, and that's what the tools detects and learns and models, puts that into a model. The result of that is that using this tool can provide more automated learning and modeling of the behavior without the need to set up, rules or thresholds manually and configure these thresholds. It also results in greater predictive detection of performance behavior anomalies and can be used for scoping, the impact on the system. It also provides, because it makes use of large volume of data automatically, it provides a more robust guidance to accelerate the triage of performance problems and do RCA, root cause analysis, across multiple IT domains, being network, application, servers, or storage. I'm going to show an example. So this thing, invariant relationships, right? That's a fundamental concept in this specific technology. I'm going to show an example using this e-commerce application, let's say, that runs across multiple domains. There's a web server, application server, a database server. Of course, performance metrics can be collected throughout this environment. Let's say metric A, B, C, D, such as these are Java application related metrics, number of HTTP requests at a given time, JBoss, EJB session invocations per interval, right, for example. So let's take two of these metrics, A and B, and I'll show how it works. So when metric A varies over time, metric B varies. The tool is going to learn if there is a correlation and detect this relationship. We call that this invariant relationship. And it's going to establish the relationship in terms of a function, right? So that B is a function of A, for example. So it knows that now. It's going to learn that over a period of time during normal operations. So now it's going to use that when the value of metric A, say, varies. Now it can calculate the predicted value of B, right? We call the forecasted value or calculated value of metric B, because it knows B is a function of A. If it also knows the actual value of B, that's what's being collected, right, from the application. And when the actual value of B is equal to the calculated or forecasted value, that's normal behavior, no problem. So that you can use that in monitoring. However, if the actual value of metric B deviates from the calculated value, that's an anomaly. That's the beginning of an anomaly. And that's what constitutes an anomaly for IA. Of course, IA will do this with a large amount of data, right? Tens of hundreds of thousands, not only a pair, but that's the idea. I'm going to show some benefits, right? Try to illustrate some advantages of this concept by, again, using an example. Again, two metrics, B and C, EJB session invocations per interval, and XML SAX parser responses per interval. This is real data, by the way, that we plotted on this chart. And same as before, when metric C varies over time, metric B has certain behavior. The tool has detected that there is a correlation between those two series, those two values, metrics. In fact, it has put the relationship in an equation, which is shown at the upper left corner there. Not that you need to know about this, but this is the way the tool would work. And you can see some kind of a time series that uses the value of B and C at time t, at t-1. It even goes to t-2. So it's a kind of regression time series. First thing to notice maybe here is that it's not obvious that there is a correlation, at least to the naked eye, between those two curves. So it's not a simple correlation detection. It's a much more complex algorithm. Second thing to say is that, so the way it works again is that when metric C varies over time now, IA can calculate the value of B, in green dotted lines, because B is a function of C, right, at each given point in time. And when the value of B, actual value of B deviates from the calculated value, that's the beginning of an anomaly. And the first thing to say is here, if let's say B was a KPI and was being tracked by a conventional, say, monitoring tool, not IA, right? IA does not use thresholds. But let's say there was a threshold on the value of metric B to, let's say, 1,000 invocations per interval here. We could still be below the threshold, right? So nothing would be detected at this point because the values of the threshold is not violated yet. Maybe later in time, if B continues to increase, then it's going to violate these thresholds. But that's later, whereas IA, as soon as the correlations starts to break. We call that a broken invariance. That's the beginning of the anomaly. So more predictive here, the detection of anomalies. Then what you might say, some users would do is say, well, to catch these, deviations on the metric, on the value of B, I'm going to set a threshold tighter, but that has the risk of creating false alerts because then spikes, right, can also violate those thresholds and generate alarms or something. So, whereas here on the left side of the chart, of the diagram, as long as the relationship between B and C metrics hold, there is no anomaly for IA. Only when it breaks, it constitutes an anomaly. So simply put, that's the way it works. So three advantages that I tried to illustrate. First, the predictive, right, capability. So you'll be able to predict developing problems before major business impact. That's kind of the result. Providing superior, more accurate detection of developing problems. So being able to build a model based on relationships that maybe simple correlations would miss. We saw the example before. It was not a very obvious correlation. Being able to detect anomalies that conventional threshold or dynamic thresholding would miss. There are other solutions that are based on, that include analytics as well, but they build a baseline reference, they call it, baseline model, and it's still based on the thresholding method, so with the type of possible disadvantages that I mentioned before, such as false alerts, and so whereas with IA it can eliminate false alarm storms, and the whole thing is automated, right? So the discovery, the learning of the model does not require manual settings of rules or thresholds, which of course frees up the time and staff resources that are usually dedicated for setting up and configuring these thresholds and deciding which ones are the important one to track. I'm going to show the overview of the usage model or usage case for this type of tool. So two phases here. One is creating the model or models. There can be multiple models to replicate your environment, meaning to reflect seasonality, to show that, say, different times of the day, morning is different from afternoon, or nighttime is different from the day, weekends are different from weekdays, and so forth. But during normal operating periods, performance metrics are being collected and used, and with that, IA built a model, which we call the reference model of these invariant relationships, right? For that, there is no thresholds or learning period required. It's also fairly fast. IA can learn and see the relationships or correlations between metrics after about 100 data points. So 100 data points, if the data is collected every minute or used for every minute time intervals, that's 100 minutes, so about an hour and a half, or let's say 2 hours. If it's every 5 minutes, you get the model based after 8, 10 hours, let's say 12 hours, right? 12 hours. So second phase 2 now. So during monitoring, the performance metrics are being collected and now analyzed against this reference model, and so that when there is an anomaly, IA will detect this anomaly in a predictive way and be able to send alerts to, of course, to other dashboards or domain managers. And then IA can be used also for triage and get some information on what caused this developing performance anomaly. and perhaps for final resolution, the domain manager for the application will be used. And for example, APM Introscope, which I will show in the demo. So two major use cases here: the predictive detection of anomalies, and then use for increased guidance during triage. I'm going to show a customer use case showing that was done at a large airline company in Asia, in Japan, and they experienced a performance degradation problem on their ticketing system, which of course impacted flights and passengers, and had also major impact on revenues. The ticketing system ran on the Oracle service bus, which ran on WebLogic suite. So the performance metrics were being collected from that application through CA APM Introscope, as well as SAR and GC, and then analyzed by Invariant Analyzer, IA. There was about 2,800 performance metrics being collected in that case. The analysis showed that the problem started developing several hours, 2 or 3 hours before the performance degradation were actually reported. So the data was being collected and was available. Now this was done in after the fact reactive mode for troubleshooting. So it could have, because IA was not used in real time with the APM Introscope at that time, it could have prevented the problem. That's what this shows. All right, I'm going to move to the session that just positioning again how this technology NEC IA can be used with CA APM Introscope, and in this case we also are going to use a CA SOI, Service Operations Insight, for a business service level view of of the monitoring. So just a recap on the CA SOI. Some of you may be using the product, some of you may not. So Service Operations Insight from CA is all about business services, right? About the health, quality, and risk of business services. And also then to optimize IT operations by reducing cross-domain triage and accelerating or reducing mean time to repair by automating the discovery and modeling of the business services, by doing analysis and alerting on service impacts and risk analysis, and then use the tool to interface with, or to escalate to the appropriate support level for remediation of including data centers and cloud automation. Now, using IA with SOI brings the added value. So SOI users would use SOI to improve the quality of service, right, by pinpointing to issues that impact the business services, to improve the predictability of the service by pointing to risks to the service, and finally, as I mentioned, to optimize operations with the automation of escalations and remediation of the performance anomalies. Now, with IA, in addition, users will be able to enhance the visibility of business dependencies between business services. Also, to enable proactive management of the business service performance, and then can be used to help prioritize the remediation of a business service performance, based on the importance, I guess, and priorities of and impact on specific services. So the addition of domain managers with the addition of IA and SOI results in cross-domain predictive problems avoidance for system services. This is a model of what the solution can look like, right? Where's the role of IA in this workflow, so to speak? So on the left is the domain managers, for example, APM Introscope for application performance management. IA uses the data coming from APM, the performance metrics, in real time, and analyzes the data, and then when there is a performance anomaly, detects and provides information, and is able to send that information to SOI, such as an alert, right, to the appropriate business service to alert at that level. And then that alert can be escalated, and SOI will manage the automation and the ticketing, right, integrate into ticketing systems for further investigation and resolution of that problem. The benefits of this workflow, I would say, provides an enhanced, greater understanding of the dependencies between the business services based on the discovery of these relationships that I described earlier, right? The behavior relationships between the various components of the IT environment. It can also minimize the impact on the systems and users based on the detection and analysis of these behavior anomalies. So the tool can be used to analyze the behavior analysis, and then can be used to prioritize the tickets and trigger data center or cloud automation based on the impact on specific business services based on the priorities. So I'm now going to move to the question, and unless there are the questions at this point, I'm going to move to the demo part. I'm unable to see if there are questions. I think we're okay. Let me go back to full screen here. So in the demo, we're going to show a use case, illustrate a use case of using this tool, IA, with CA APM Introscope, as well as CA SOI, as I mentioned. For that, we'll use this e-commerce application system that replicates multiple domains, right, including Java servlet, application server, and database servers. And during the demo, we're going to increase the load on one of the servlets, the place order servlet specifically, illustrated in the diagram below here, which will result in performance degradation where the user will experience slow responses, right? And eventually, actually, there is no responses because I think that if we wait long enough, the system would hang. What we'll observe during the use case of the demo is, okay, here's the environment. So at the bottom is the application being monitored by APM Introscope on the right here, bottom right. Performance data. That performance data is being used by IA, and SOI is monitoring the environment. So what we'll see is first an alert coming from IA to the SOI dashboard, which is kind of the overall monitoring dashboard. Then the operator will be able to use IA and start IA from SOI to see where this alert came from and what information is available in IA on this alarm. And then finally, based on that information, we'll be able to use the domain manager CA APM Introscope and start Introscope from IA in context for final resolution. So that's what we're going to show. With that, I'm going to, I guess, share my desktop to see some screen. Okay. I'm going to switch to All right. I hope everyone can see this. If not, please shout or let me know, Manish, if you're online.
I can see you, JP.
Thank you. So I just switched system, showing my different desktop. And so what we're seeing here is on the right-hand side is the IA GUI, which there's not much to see yet because we just started the load on that servlet, right, called the place order servlet. On the left is SOI, which is being used to monitor this application, e-commerce application. There are some business services here, one called test, one called trade service, which is also replicated in IA. And then below is the SOI console that shows the topology of this application with the various configuration items and the topology, again, of this environment. So here, APM is monitoring this application. As I said, I think there's about 530 metrics being collected by APM for this demo. APM collects every 15 seconds, right? IA analyzes every 1 minute. So there's this screen up here is going to refresh every 1 minute and performs an analysis of the data set every 1 minute. There's something that just happened here I want to bring your attention to. There's an alert that was just triggered on the IA screen. I'll come back to that later. And here also there's something happening, something developing, which I will explain. The data is being collected from the application server, which is Tomcat, and also SOI is picking up the alert. So this alert from IA is now being sent to SOI. Anyway, the model was built earlier. So there is a reference model that includes 140 metrics or so, out of which IA detected 2,500 invariant relationships. So the IA user interface on the right here, and that window on the right, I'll come back to it later, but what's showing at the top here is called the anomaly graph. That shows the number of these invariant relationships that I showed earlier that are broken at the given time. So when it's all blue, there is nothing to report. There's some noise here, and the orange part indicates the percentage of invariant relationships that are broken in the model. And the y-axis is the percentage. You can see 50% would be the max here. So there is orange, in other words, indicates the beginning of an anomaly. Anyway, I'm going to close this for now, close IA, because this is where the operator will start. They would see the alert coming from, well, they would see an alert on the dashboard first on these business services. on the health. Then in the console, they can get more information and look at this specific CI for Catalyst Intro Tomcat agent that turned red. So there is something going on. At this point, I can see also that this alert come from, I want to find out, oh, here's the alert that triggered this configuration item to turn red. I can see it came from IA. It says it's an IA alert. And there's some information, of course, on the time and when it was sent, and some names on the metrics that were in, and components that were involved with this alert. So the use case we are proposing here, we'll keep it simple for now, is I can see this alert came from IA, so I'm going to start IA, right, from SOI, and I can do that here also. I need to, oops, I closed it earlier. And starting IA, I'm going to find out what metric created, what component did this alert come from. And so essentially I'm going back to where I just was before. Need to be automatic update. And change the scale. And it's okay. In this case, Sandy says, am I looking at the right? Yeah, okay. I need to maybe expand this. There was some noise earlier. Here we go. So what we are looking at here now in IA is I'm just going to expand that screen. The top part, like I said, is called anomaly graph. It shows the number of invariant relationships that are broken at a given time. When it's blue, that means nothing. There's none. Orange is the beginning of that anomaly, and there are broken invariants. And the y-axis is the percentage. So now there is, at the top would be 50%. So we're probably at 30% of the invariants in the model are broken. You can see the screen refreshing every minute. This is all based on data coming from APM Introscope, right, real time. Information on that alert from IA. This is the alert that was sent to SOI in the first place to the appropriate business service, alerting the operator that something was happening, and that's why we're now using APM. Some information that can be used here in APM. This is the list of we call anomalies. So the actual metrics that are part of that have broken invariant relationships, right? And then for each metric, let's say place order responses per interval. That's one metric that is being collected, and usually it has correlations and invariant relationships with all the metrics below here, but at the moment these correlations are broken. And for each of the metric, I can see the behavior, of the actual values, and also the calculated value. That's the green dotted line. I don't know if you can see that here, and that tells me there is a difference between actual and forecasted value, which is highlighted in red here. So this type of information could be used for someone with domain knowledge, right, to understand what's going on. Now, to keep it simple, in this case, what we say is, well, I can see that and also these anomalies here are ranked by order of severities, based on the number of metrics that have broken relationships, and as well as other factors that IA calculates and ranks these anomalies. But here I can see that the top anomaly has something to do with the metric place order responses per interval, right? So this is for the guidance here is to take the top anomaly, or some of the top ones, and investigate further by starting the APM investigator. So I'm starting the APM investigator in context from IA, which is what I just did. This is APM, and you notice everything is still green on the APM Introscope. There's a dashboard for APM Introscope as well. Here is the investigator looking at the responses per interval, and I think I need a bigger scale. I'm going to change the scale to let's say 1 hour. And so this took me to metrics being related to the servlet place order, specifically the responses per interval that had broken relationships. And in APM, I can see that definitely at the time when IA sent that first alert was 8:35, around there. We're on the West Coast here. Something happened to the number of responses per interval on this servlet. It increased dramatically, right? So something was happening. And if you remember in the demo what we did to simulate the performance problem, we increased the load on place order servlet. So that kind of confirms what IA had detected. So this shows the how to use the tool to have some information, to have guidance as to where to look for, perhaps using APM Introscope to accelerate troubleshooting. In fact, let me go back to, we recorded this earlier, and I'm trying to show what it would look like. This is a video now. I'm switching again the screen and to a video of the same environment, the same demo environment. And if we waited long enough and looking at the APM dashboard, this is the place responses per interval. 30 minutes later, we would observe that the APM dashboard also picks up the alert, and the light for place order servlet first turns into a warning, and then the red traffic stop sign confirming the work with where the performance anomaly came from. So that's basically the end of the demo. At this point, I'd like to take any questions that you might have, and also just wrap up right with this summary of the benefits that I tried to illustrate with both the explanation of the technology and also the demo. So the predictive aspects, right, of detecting behavior anomalies, that's what the tool detects. To be able to detect reliably problems before and avoid business impact, user and service and systems level impact. The automated discovery and modeling of the IT environment using large amounts of making use of large amounts of data without setting up thresholds or rules manually. So resulting in being more robust than, let's say, conventional monitoring, because it's more encompassing. It uses all the data available from APM. And then it's designed to integrate with your existing workflow. I showed an example. You're going from, building this tool into the CA workflow. If you have any questions, also feel free to follow up. This is my contact information. My email address, feel free to call. And also, there's a website here where you can reach out and contact me through that website at necam.com/IA. That's maybe the simple one to remember.
Do we want to open up the floor for questions?
Yes.
Again, if you would like to ask a question, please press star, then the number 1 on your telephone keypad. We'll pause for just a moment to compile the Q&A roster.
I see a question from Azim on the Q&A about how mature is this tool IA. So the tool is, we've been, used in, NEC is a Japanese company, right? So we have customers in Japan. In the U.S., we're going to market and working with customers and partners. I should have said also that tool IA can be used in 2 use cases, 2 modes. It can be used as in reactive mode in offline. So using performance metrics and data sets from APM and other domain managers to see what happened after a performance anomaly. So to help troubleshoot and accelerate time to resolution, basically. That's one use case. The other one, of course, is when the tool is integrated with the domain manager, such as CA APM and SOI, used in real time, and that's when you benefit from the predictive aspect, because then you see IA will pick up the anomalies as they develop. Right. So thank you.
There are no questions on the audio side.
Okay. Since there are any questions, I guess we can open it up. Are there any other questions outside of the presentation? Anything regarding the next webcast or even CA World? Anybody like to ask?
Again, if you would like to ask a question, please press star, then the number 1 on your telephone keypad. There are no questions on the audio side, sir.
Okay. So I guess we will go ahead and end this webcast, and I thank you for participating. And please go ahead and rate the value of today's webcast, if you don't mind, before you log out. We'd really appreciate it.
Thank you all for watching.
And I hope